What if the rocks you see on a daily basis are not just rocks? What if there is more to it? Rocks can be found all over the world, such as when a native from the Philippines comes across a rock that she believes is a very uncommon rock while exploring the mountains near an erupted volcano many years ago. Jam requested the advice of multiple geologists in order to learn more about the rock he had discovered.
This rock is indeed a very uncommon rock. We can identify its physical and chemical properties. So, what are those? Many physical properties including color, crystal form, hardness, luster, cleavage, and density can be used to distinguish rock-forming minerals. Many of these properties can be seen without needing present laboratory equipment. The chemical properties of minerals are determined by their chemical formula and crystal structure. They can also be recognized by their solubility in blood. So, how can we know which type of rock is this? There are three types of rocks: sedimentary, igneous, and metamorphic.
Sedimentary rocks are created by the consolidation of the sediments that accumulate on the surface of the earth, on dry ground, or underwater after settling out of water, ice, or air. When a molten earth material known as magma cools down and solidifies, producing crystals, then igneous rocks are created. As a result, they exhibit a connecting crystalline texture.
All they began as a different kind of rocks, metamorphic rocks have undergone significant alternation from their igneous, sedimentary, or previous metamorphic form. When rocks are exposed to extreme temperature, high pressure, hot mineral-rich fluid, or more frequently, some combination of these conditions, metamorphic rocks are created. You can send us a sample of this rock and ship it to our facility to obtain more information about what rock it is.
Jam, according to the geologists, sent a sample to their lab and waited for the results. After a few days, Jam received a phone call from one of the geologists.
Based on the data, this rock is indeed the result of volcanic eruption, indicating that this is the case. This rock was developed as a result of volcanic eruption caused by an earthquake, which forced the rock to experience stress. Rock can experience three different types of stress. The first of which is compressional stress. When compression happens, the rock will be squeezing or pressing against one another. Second, there is tensional stress, which pushes the rock apart or causes them to stretch. Lastly, shear stress results in rock rocking and sliding past one another while moving horizontally in opposite direction. We learn more about plate tectonics and how it results in different plates motion by looking more into this rock.
Yes, during the course of our research, we discovered that plate boundaries are classified into three main groups. These three are the transformed, convergent, and divergent plate boundaries. The first is that a convergent plate boundary is a plate boundary when two tectonic plates are moving toward or colliding with one another. Within this boundary, plates converge in three different ways. The first one is the oceanic crust to continental crust, which is a convergence of plates carrying continental and oceanic crust. The convergence of two plates carrying oceanic crust is the second type, known as oceanic crust to oceanic crust. Lastly, continental crust to continental crust, which forms when two plates carrying continental crust collide.
The divergent plate boundary, also known as a plate boundary, where two tectonic plates go apart from one another, is the second boundary. There are two ways that a plate in this boundary diverge. The first of which is the oceanic crust, which occurs when oceanic plates drift away and cause seafloor spreading cracks. The second type is known as a continental crust, It is a movement that causes rifts to occur that the crust grows wider and gets thinner as the plate separates.
The final type of plates boundary is referred to as the transform plate boundary. This boundary occurs when two tectonic plates glide horizontal alongside each other. Transform boundary are placed where plates slide sideways past each other. Many transform boundaries are found on the seafloor where they connect segments of diverging mid-ocean ridge.
Thank you for the wonderful information you got there. I will surely take note of that.
indicated that this rock was formed by a volcanic explosion many years ago, correct? So how do stratified rocks ages become determined?
When attempting to determine the age of stratified rocks, absolute dating and relative dating are the two main methods used. First, relative dating is used to identify the chronological sequence of historical events by comparing the age of various artifacts, without establishing the precise age of objects. This method shows that where it falls in a time frame. Second, absolute dating proves the object's true age. We can use this technique to determine the rock's approximate age in years. Radiometric dating is a primary method used for absolute dating.
When I heard the term continents, I immediately thought of the lines of evidence of continental drift theory. So what are those?
The continent resemble puzzle pieces that have drifted apart they seem to fit together, and now as a jigsaw fit. This is one of the 5 lines of evidence for the continent drift theory. The second theory is puzzle evidence, which show that the continents were previously connected due to remains of similar plants and animals that have been found in rocks and similar age along the coastline of numerous continents. The geology of eastern South America and West Africa was mapped, providing a third line of evidence. Evidence of rock. Asian rock outcrops, cratons, more than 2,000 million years old, were continuous from a continent to the other.
The fourth evidence, which is the evidence of climate change that supports the movement of plate movements, includes coast found in Antarctica, limestone deposits found on reefs far from the equator, sediments and rocks left behind by ancient glaciers found on the many continents close to the equator, and much more circumstantial evidence. The continents have migrated apart, which is the most likely explanation for the location of these deposits. The continents move through the polar, temperature, and tropical climatic zones as they migrated. The final piece of evidence, which is the evidence of magnetic polarity, that shows that neither the continent nor the location of its rocks contradict the direction that magnetite crystals in recently formed volcanic rocks point. These were some of the last parts of the puzzle that helped current plate tectonic come into being.
I appreciate all your knowledge about this. To add further information, let us talk about fossils. How are guide fossils used to define and identify subdivisions of geologic timescale? The geologic timescale can be defined and identified with the help of guide fossils, also referred to as index fossils. These fossils are used as reference points for comparing and dating sedimentary layers and rocks from various sites, making them essential.
How can the Earth history be interpreted from the geological timescale? The geological timescale, a framework for dividing the history of the Earth into separate periods based on key geological and biological events, can be used to interpret the Earth history. This scale enables scientists to comprehend the series of the events that shaped the Earth over billions of years.
As many people may encounter rocks in their daily lives as common things, this shocking event will serve as a reminder to everyone that common things can make life more interesting.